Hello, mathematicians. Welcome to another lesson. This is Mr. Garcia, and today we're on lesson 8.4, which is talking about interior, exterior, and semi-inscribed angles of a circle. Let's look at our objective. I can find the measures of angles that are located inside and outside of a circle. So last time we started talking about the inscribed angles, which have their vertex on the circumference of the circle. And we know that for that, the measure of the angle is half the measure of its intercepted arc or its corresponding arc. Now, this is also true for semi-inscribed angles of a circle. And what we mean by semi-inscribed is that one side of the angle is inside the circle, but the other side is not. The other side is part of a tangent. And remember that tangents are lines that only touch the circle at one point. So where they touch also happens to be the vertex of this angle. But the vertex ends up being on the circumference of the circle. So the same formula that we use for inscribed angles is also used for semi-inscribed angles. The measure of this semi-inscribed angle is half the measure of the intercepted arc. Now this time though, the intercepted arc actually starts at the vertex of our angle and intersects at another point on one of the lines of the angles. So this one is pretty straightforward because it's just like the ones that we've already talked about, the inscribed angle. But let's take a look at an example. So here we need to find the measure of angle QPR. So as always, a good rule of thumb is to highlight the things that we're trying to find, the information that we're given. So I'm going to outline angle QPR in green. So here I have point Q, here's point P, and here's point R. So my angle would look like that. So I'm going to be looking for this measure right here. Now I can also see that this angle does intersect an arc. And that arc, I'm going to outline it in pink. And that arc happens to be PR. I'm also given a measure for this arc, which is 148. So since I know that the measure of arc PR is equal to 148 degrees, based on our formula, the measure of the angle is half the measure of the arc. So to find the measure, and I'm going to do this one in green actually, to find the measure of angle QPR, then that's going to be equal to 1/2 times the measure of arc PR. And since we know arc PR is 148, that means we have 1/2 times 148, which is the measure of angle QPR, which ends up being, and actually I can just write it down here, 1/2 times 148 is 74 degrees. So nothing too difficult here. It's all pretty straightforward. Just find the measure of the intercepted arc, divide it by 2 or multiply it by 1/2, and you've got the measure of the angle. Now, if you start off with the measure of the angle, then you're going to work backwards. Instead of dividing by 1/2, you would multiply the measure of the angle by 2 to get the measure of the arc. And we can do that to double check this. So if I have 74 times 2, that gives me 8. 7 times 2 is 148, which is the measure of the arc. So we know that our answer is correct. So let's take a look at the next set of angles. These are the interior angles of a circle. Now, you know that the word interior means inside. So when we talk about interior angles of a circle, the vertex of the angle is anywhere inside of the circle, but not on the circumference. So the vertex will be anywhere inside of the circle, but it can't be on the circumference. If it were on the circumference, it would be one of these, a semi-inscribed angle or an inscribed angle. So being an interior angle, to find the measure of that interior angle, we have our formula here. And explaining it in words, what it says is the measure of the angle is half the sum of the measures of the intercepted arc, which is B in this case, and the vertical angles intercepted arc, which is C. Remember that vertical angles are directly across from each other. So if I have angle KHG, which is here, then the vertical angle of KHG would be this one right here. And I'm going to make up some points here. Let's say ST. So in this case, we know that the measure of angle THS is equal to the measure of angle KHG. But to find the measure of one of these angles, since we know they're equal, to find the measure of one of them, we need to add their corresponding arcs and divide that sum by 2 or multiply it by 1/2. Either one will give you that answer. So it's a little bit complicated to say it in words. So why don't we go through an example so you can see how to use it. So here we need to find the value of x. The value of x corresponds with the measure of angle LGK. So essentially, we're looking for the measure of angle LGK. And I can write that in blue. The measure of angle LGK. Now we also have 4 angles here, and like we said earlier, we need to identify the vertical angle to angle LGK. So remember, vertical angles are kissing angles directly across from each other. So my vertical angle to LGK must be HGJ. And I'm going to write that in green. So I know that these two are equal. HGJ. Now it's important for me to identify these vertical angles because those show me which arcs I'm going to add together. And I'm going to outline those arcs in purple now. So I'm going to outline the arc corresponding to LGK, which is this one right here. But I also need the arc that corresponds to its vertical angle, which is arc HJ here. So the measure of arc LK and the measure of arc HJ are going to be added together to find the measure of angle LGK, or x in this case. So let's write it out. We have x equals, we know that our formula is 1/2, and we're going to be adding the measures of these arcs. 116 plus 47. And now all we have to do is solve it. So 116 plus 47 is 163. And I know I'm going to be multiplying that by 1/2 to get x. So if I do that, then my answer is 81.5 degrees. So the measure of angle LGK, or x in this case, is 81.5. Again, the thing to remember here is that, first of all, this formula is used with interior angles, which means that my vertex for the angle has to be somewhere inside the circle and not on the circumference, inside the circle. Second, I need to be able to find which are the arcs that I'm going to be adding together. And that depends on which angle I'm looking for. So I know I'm going to be using the arc that intercepts the angle that I want to find, but I'm also going to be using the arc for the angle across from it. Keep that in mind, because that's where people get confused on this one. And if you have questions, remember, reach out to us and we'll help you out. All right, so let's move on to the next set of angles, which are the exterior angles of a circle. Now you see that there are three cases here. I can have an exterior angle with two secants. I can have an exterior angle with a secant and a tangent. And I can have exterior angle with two tangents. Remember that the tangents are the ones where it intersect only once at one point on the circle, but the secants are the lines that go through the circle, and it intersects at two different points. Now, the reason why I have all three of these together is because, fortunately for us, the formula for these three cases are all the same. The measure of angle A in all of these cases is equal to 1/2 times the measure of the arc B here in red minus the measure of the arc C. Now let's take a look at the other information we have. The vertex of the angle has to be outside of the circle. Remember that exterior means outside. So that vertex has to be outside of the circle. And again, it can't touch the circle. It can't be on the circumference of the circle. It has to be outside of it, the vertex. Also, the measure of the angle is half the difference. And remember that word difference means subtract, half the difference of the measures of the intercepted arcs. Now, I'm not differentiating here because there will always be two intercepted arcs in these cases. One where one set of points cross the circle, and the other where the other set of points cross. Now, in a secant, you can see that their two arcs are separate. I have one big arc way over here, and I have the little arc over here. But when the tangent gets involved, it's a little bit more confusing. With the tangent, the arcs separate at the point where the tangent crosses the circle. So here in blue is the smaller arc that goes from that intersecting point on the tangent to the intersecting point of the secant. The bigger arc starts at that same intersecting point of the tangent and goes to the other point of the secant. And when it's two tangents, the arcs are actually touching each other at both places. So those points of the tangents mark where the arcs finish and begin. So you have the red arc all the way around here, the big one, and you have the smaller arc inside here. You see that they both start and end using the same points. So it's a little bit tricky, but let's go through several examples so we know how to work these problems out. First, let's look at the case where we have two secants. Our problem is to find the measure of angle RQU if the measure of arc RU is equal to 31 degrees and the measure of arc ST is equal to 85 degrees. I forgot my degree symbol up here. So first, since I have nothing marked on my diagram, let's start by finding these arcs and labeling them. So I'm going to use red and green. So the measure of arc RU is 31 degrees. So I'm going to find arc RU first. And here's R and here's U. So the arc must be here. And since I don't have the arc measurement labeled, I'm going to label it. So I have 31 degrees for that arc. Now I'm going to find the other arc, ST. So here's point S, here's point T. So I know that my arc goes through here. And this is 85 degrees. So I'm going to write 85 degrees for that arc. And we're trying to find the measure of angle RQU, which I'm going to highlight in pink. So here's point R, there's point Q, and there's point U. So this angle right here. Again, that's going to be in pink. And let's call that X, just to make our equation a little bit easier to write out. So I'm looking for X here. I'm looking for the measure of the angle. And I see that I have two different arcs being intersected. I have arc ST and arc RU. I also know that the vertex is on the outside of the circle. So this is an exterior angle, and as such, we're going to use the formula for an exterior angle. So I have the angle, which in this case I'm calling it X, equal to 1/2, then I have parentheses, and inside the parentheses, I'm going to be subtracting the measures of the arcs that I have. So I know I have 85, and I'm going to subtract 31. So 85 minus 31 gives me 54. And I drop the rest of the equation. So now I have X equals 1/2 times 54. And 54 times 1/2 gives me 27. So the measure of angle RQU is 27 degrees. So with two secants, it's a little bit easier to tell the two arcs apart because, as I said earlier, the two arcs are separated. But let's look at the case where I have a tangent. That's going to be a little bit more complicated. So let's take a look. So here is a secant and a tangent. I need to find the measure of arc XZ if the measure of angle XYZ is equal to 68 degrees. So again, I'm going to start by highlighting my given information. My angle, I'm going to highlight it in blue. And I'm looking for angle XYZ. So here's point X, here's point Y, here's point Z. So here is my angle. 68 is already there for us. So I'm just going to put the little mini arc there to know that 68 belongs to the angle XYZ and not the arc XZ. In fact, that's what we're trying to look for. So let me get my red highlighter. And we're going to color that arc in red. So I have arc XZ. Now, I know that since this is an exterior angle, I have the angle, I have the vertex outside of the circle. So I know that there must be two arcs here that I'm going to be subtracting. Now I have one of them, which is arc XZ, right? These are the lines of the angle. Now extend that highlight a little bit so we can see those lines. So I have my first arc here, XZ. So if I keep following this line, I see that I also have an intersection point here. So let me get a purple highlighter. And I'm going to highlight this arc. Now here I made a mistake. And you guys might make the same mistake too. I'm making it right now so that you guys can see. This purple outline that I made, notice that it's not inside of the angle. My angle are these blue lines. So think of it like a fence. And this purple arc is outside of the fence. I don't want that. If you have an arc, you highlighted that's outside of the angle. You highlighted the wrong arc. So don't do that. Be careful about that because I know some people are going to make that mistake. The arc that we want has to be in between these two blue lines. So if I look at my intersecting point again down here, point V, I know that it can't be the outside one. So it must be this arc that goes through here. Now, how do I know where to stop this arc? Remember that one of these points, X here specifically, is where the red arc starts. So if one arc starts there, then the other arc must finish there. So at that intersection point X is where my two arcs are separated. I have the purple one going this way and the red one going that way. So with tangents, that one intersecting point tells you where those arcs are going to separate. So keep that in mind. Now I have my two arcs. And I see that the second arc here, which is arc XWV, because it is a major arc, is 224 degrees. So again, I'm looking for the measure of arc XZ. So why don't we call that one, let's call it K. Just so that I don't have to keep writing measure of arc XZ in my equation. So let's set up our equation. First, I'm going to write it out the way that we have it in our formula here. So I'm going to start with the measure of the angle. So the measure of angle XYZ is equal to 1/2. Then I write in my big arc, which is in this case is the measure of arc XWV minus the measure of the smaller arc, measure of arc XZ. And I close my parentheses. So that is the formula in symbolic terms. Now I know some of these and I don't know some of these. So let's plug in what we do know. I know the measure of angle XYZ is 68 degrees. So let's write in 68 here, then equals 1/2. The measure of arc XWV, I know that to be 224. So let's write that in. And the measure of arc XZ is what I don't know. That's my unknown, but I'm using the variable K for that. So let's write in K. Now we're ready to start solving this equation. When I look at this, I need to solve for K, right? So I need to get rid of everything around the K. Now, right now, the K is in jail. It's inside these parentheses. So I need to be able to get rid of these parentheses. But remember that parentheses usually means that I'm multiplying everything inside here by something. And I know that I'm multiplying that by 1/2. So I need to find a way to cancel out 1/2. Well, one way that I can get rid of 1/2 is to turn it into 1. But how do I turn 1/2 into 1? Well, if you know 1/2, that also means divide by 2. So what I can do is multiply by 2. But if I multiply by 2 on one side, I need to multiply by 2 on the other. So multiplying by 2 is going to cancel out my 1/2. On this side, I have 68 times 2, which is 136. Now on this side, I'm just left with 224 minus K. I don't need the parentheses anymore because I already got rid of the 1/2. I'm not multiplying this by anything anymore. So I get rid of my parentheses and I'm good to go. So since I'm solving for K, I don't have any K's on this side. The only thing that I need to get rid of is this 224. Since it's positive, I'm going to be subtracting 224 from both sides. So that cancels this out, and I'm left with k, but not just k, because I still have the negative, the minus in front of k. So this is going to be negative k. And on the other side, I have 136 minus 224, which gives me negative 88 when I subtract those. Now, since I want k, I don't want negative k. So I need to change that negative to a positive. One way that I can do that is divide by -1, because the number will stay the same because I'm dividing by 1, but the sign changes because I'm dividing by that negative. Negative divided by a negative becomes positive. Now I'm going to divide by -1 on the other side too, because whatever I do on one side, I have to do to the other. So negative divided by negative also becomes positive over here. So k is equal to 88, which means that the measure of arc XZ is 88 degrees. Now this one is a little bit trickier because I'm kind of working things out backwards. Instead of giving you both of the arc measurements, I gave you one angle and one arc and told you to find the other arc. But this is to show you that our formula stays the same. In fact, our method of solving these pretty much stays the same. If you remember, all we have to do is plug into the formula what we do have and solve for whatever we don't have. So as long as you have the formula, this down here, and you know what to plug in for the angle, you know what to plug in for the B arc, and you know what to plug in for the C arc, then you can solve for anything that you're missing. Let's take a look at the last example here, which uses two tangents. Another name for this type of angle is a circumscribed angle, because this angle touches the circle but still stays only on the outside. If you remember, inscribed angle means that it's all on the inside. Anything that's inscribed is completely inside a circle, but anything that's circumscribed is outside the circle. Now in this case, we need to find the value of x. We're given the two tangents, we're given the angle measure here, and we have expressions for our arc measures. So let's write out, or let's highlight first what we have here. So I'm going to highlight the lines so that I know where my angle is at. And now knowing where the angle is, I see the points of intersection. So now I'm going to highlight the arcs that I have. So I'm going to start at point E for one of my arcs because the line is crossing the circle at this point. So I'm going to highlight all the way around. Now for my other arc, it must start at this point as well. And I'm going to keep going till I get to the other intersecting point. And this is what I was talking about earlier. Notice that since both of my lines here are tangents, both of my arcs, this one EFG and EG, pretty much connect to each other. The only way to tell them apart, or the thing that separates them, what I'm trying to say, is that that point where the line crosses, where the tangent touches the circle, is the point that separates the two arcs. So keep that in mind. If you have a problem with two tangents, the point where those tangents touch the circle is where the arcs are going to separate. Now that I know all this, let's write down our formula so we can plug in what we have. So remembering it from our page, we have the angle first, which in this case is going to be EDG. So the angle EDG, and not 6g is equal to 1/2 times the difference of the arcs, which I'm going to start with arc E, F, G, and difference meaning minus, then arc EG. And I close my parentheses. So again, I'm going to plug in what I have into my equation. Now, since I'm working with expressions here, it is going to be a little bit tricky. So feel free to pause the video and go back if you did not understand how I did something. Okay, I'm going to try to be as thorough as I can. So make sure you stop the video, go back if you didn't understand how I got something. So I'm going to start with the angle, and I know the angle measures 73 degrees. So I'm going to write in 73 equals 1/2. Now I have the major arc EFG. The expression for this arc is given as 15x plus 43. Now just for convenience right now, I'm going to leave this expression in parentheses. I don't really need the parentheses here for this expression because I'm not multiplying it by anything. But I'm putting in parentheses right now just to help you see the difference when I plug in one arc and when I plug in the other. Now I'm going to subtract, and then I have arc EG. The expression for that one is 9x minus 19. Again, I'm going to put that in parentheses. I have 9x minus 19. I close that parentheses, and then I close the big parentheses. So here's my equation. It looks confusing, but remember, all I'm doing is substituting what I have for each part of the formula. I know the measure of this arc, EFG. I know the measure of EG, so I'm just substituting those expressions into the formula. So let's move on. I'm going to carry over what I don't need to change. I don't need to change the 73 equals 1/2 part. And like I said, I'm going to get rid of the parentheses now for 15x plus 43. I don't have any number in front, so I don't need to multiply this or anything. So it just becomes 15x plus 43. But over here, for this expression in green, notice that I do have that negative in front of the parentheses. If you remember from Algebra 1, that means that I need to distribute this negative to each term inside the parentheses. So it's like if I have this -1 in front, and I'm going to be multiplying that -1 with each term that I have inside the expression. So -1 times 9x, for example. And all that's really doing is changing the signs that I have inside the expression. But I want you to think of it as distribution, because if this number wasn't 1, then you would also have to multiply by that number. So I have -1 times 9x, which gives me -9x. Then -1 times -19, which gives me +19. I'm going to close the parentheses, and I'm ready to move on now. Here are several routes that you can take, but I'm going to start by combining these like terms so that my equation is a little bit shorter, simpler to resolve. So I have 73 equals 1/2. I don't do anything with that yet. Now inside the parentheses, I'm going to start by combining my like terms. So my x's, I'm going to box those in pink. I have 15x and 9x, and that's it. And then my constants, I'm going to circle those in orange. And so 15x minus 9x gives me 6x. So I'm going to write 6x. Then I have 43 plus 19, which gives me 62. So plus 62. Now at this point, my expression has been simplified, but it's still inside parentheses here. And I can't just get rid of them because these parentheses means I multiply by 1/2. So just like how we worked out this problem and multiplied by 2 up here, I want to do the same thing over there. To get rid of the 1/2, I'm going to multiply by 2. Which means I need to multiply both sides by 2. So the 1/2 and the 2 out here cancel out. Then I have 2 times 73, which gives me 146. And here, since the 2 and the 1/2 canceled out, I'm just left with 6x plus 62. And from here, I'm just solving this equation like normal. So I'm going to start by subtracting 62 from both sides. Here's my line. And 146 minus 62 gives me 84. And I'm left with 6x on this side. So now I just need to divide by 6. And when I do that, my answer is 14. So x equals 14. Yeah, it's a lot of work, but it's not anything that you don't already know how to do. You know how to distribute. You know how to combine like terms because we've done that before in the last assignment. You know how to solve equations. We've had practice with that. So the most confusing thing about this is setting it up. But once you have it set up, follow what I did and you'll get your answer. All right, so that concludes this lesson. Remember, guys, if you have any questions at all, or you need us to go over this more personally on a one-on-one basis, remember that tutoring is always available. Make sure you check that tutoring schedule so you know when the math teachers are up. And remember, you don't always have to come to my tutoring. You're free to go to Miss Caddy or Miss Humphreys or whoever else to get them to help you out. But if you want to be with me, make sure that you check that tutoring schedule so you know when I'm available. Okay? So, like I said, that concludes this lesson. Go check out the assignment. If you have questions, make sure you ask. If you need more information, make sure you check out Miss Caddy's video. And I'll see you guys next time. Take care.